Good afternoon, this is Mr. Schweitzer, and for a fifth force of friction example. This particular box, 10 kilograms. The force of friction is unknown, and that is actually the question. We have a 50 Newton force. 50 Newton force causes box with 50, sorry, it would be 10 kilograms of force, 10 kilograms of mass, and it causes a net force in the x direction, which causes a motion of, let's go, 3.5 meters per second squared. Now this motion is described as an acceleration. So this is what we got. We have a net force of 50, so we have a force causing 3.5 meters per second squared. And all we're given is that the 50 newtons of force is being applied, 10 kilograms, and I want to know what is the coefficient of friction. So step one, let's draw a picture, which already is there, and label the forces. Alright, so I like to list them out here. We got our force Newton, force applied. I'm going to call this my force applied. Let's go the X range versus the Y range in different categories. Force applied, in this direction I have my force of friction, that is in the X direction, force of friction. I have my force of gravity, which is here, force of gravity, and then I have my force normal right here, force normal. Force of gravity is mass times acceleration, which equals 10 times 9.8, which is 98 newtons. My force normal equals my force gravity, which equals 98 newtons. I'm not given a direction. If I give a direction, it would be negative and positive. Alright, and then in the A direction, or X direction, my force applied is 50 newtons. My force of friction is the coefficient of friction times force normal. In this case, the X direction, this is what I want to find out here. So I got to draw out my components, which is my second step. If I have everything listed, to separate into components. And solve for what you're looking for. Now in the Y direction, the sum of all the forces in the Y direction, they're balanced. Therefore, the sum of all of them equals 0, which is equal to the force of gravity plus the force normal, and I put a negative here. Another way to write that might be force of gravity equals force normal. In this case, we don't have any equality. We have a net force. The net force of this thing, well, this was not given, but we can find it very quickly, equals the force applied minus my force of friction. So keep this in mind for a moment, okay? And let's pause that and let's find the, in this case, the net force. The whole box has a net force equaling the mass of 10 kilograms times the acceleration. The mass is 10 kilograms, acceleration is 3.5 meters per second squared. So the net force in the X direction is 35 newtons. So I have this 50 newton force here. I have some force friction taking away from that 50, giving me a net of 35. So in the X direction, here it is. This is the 35 equals the force applied, which is 50, minus my force of friction at this point. Solve for force of friction, which equals 15 newtons. Now again, I'm not giving a negative. It's always going against the opposing force, so you can put negative if you want here. This equals the coefficient of friction times the force normal, which is 89 newtons. Okay. And 89 divided by 15 equals your coefficient of friction, which should be, if that's right, about 0.15, and that is my answer. Again, there are a couple main calculations. This guy gives me my net force in the x direction, and then draw my picture, split the x components, y components, and we're all set. Thank you.